In this video, we're going to do some extra examples computing higher order derivatives, in particular second derivatives we're going to focus on here. And we're going to do some of them implicitly, so those are in example 2. So let's just start with these ones. So I want the second derivative for the function f of x is 2x to the 6th minus square root of 3x squared, or 3x. So I might want to rewrite this. So the 3 is inside the square root, so it's 3x to the power 1/2. Okay, so when I compute the first derivative, so for the polynomial bit, I get 12x to the 5. And now I'm going to have to do the chain rule here. So I bring the 1/2 down, and it's 3x to the negative 1/2 times 3. So if I simplify this, I get 12x to the 5 minus 3 over 2 times 3x to the negative 1/2. So now I want to compute the second derivative. So I'm going to do the first bit. So 12 times 5 is 60x to the 4 minus 3 over 2 times, so now I do the same thing. So I bring the negative 1/2 down. I have the 3x to the power 1 less, so negative 3 over 2. And then again, I have to multiply by the derivative of the inside, which is 3. So when I simplify this, I get 60x to the 4. Now it's going to be a positive because I have 2 negatives, and it's going to be 9 over 4. 3x to the negative 3 over 2, which we could write as 60x to the 4 plus 9 over 4, 3x to the positive 3 over 2. Okay, and this is probably how I would leave it, unless I had to do something with it. Okay, so that would be our second derivative there. Okay, let's try another one. So g of x is x plus 3 over x minus 5. So when I compute g prime of x, I'm going to use the quotient rule. So it's the derivative of the top, which is 1, times the bottom, x minus 5, minus the derivative of the bottom, which is 1, times the top, x plus 3, all over the bottom squared. Okay, so now when I simplify, I get x minus 5 minus x minus 3 over x minus 5 squared. So notice that the x and the negative x cancel. So I actually get negative 8 over x minus 5 squared. Okay, that's my simplified version. Now, if I want to take the derivative again to get the second derivative, and I have a fraction here, but I don't actually need the quotient rule because the top has derivative 0, right? So it's just a constant. So I could actually rewrite this as negative 8 times x minus 5 to the negative 2. Okay, and this is going to be a bit easier to take the derivative. I mean, you could use the quotient rule. It's fine. You just have to remember the derivative of the top is going to be 0. So one of your terms in the numerator is going to be 0. Okay, so now if I use the simplified version, and now I want to take the second derivative, the negative 8 just comes out to the front. It's a constant multiple. I bring down the negative 2, and I have x minus 5 to the negative 3, and then I multiply by the derivative of the inside, which is 1. So negative 8 times negative 2, that's 16. So I have 16x minus 5 to the negative 3. So that is actually, maybe I'll just do it over here. So I get g double prime of x is 16 over x minus 5 to the positive 3. Good enough. If you did the quotient rule with this part, you should get this. It should simplify to the same answer. Okay, now we're going to try and do some implicitly. So here's a few equations where they're not solved for y, although these ones could be solved for y. But we're going to take the derivative implicitly. So we want to do the first derivative. So we take the derivative like normal. Okay, so if I do d by dx, okay, I'm going to have 2x plus 2y times dy dx, or y prime, equals 0. So then if I solve for y prime, 2y prime is going to be negative 2x. Maybe I'll just write that. If I move the 2x over, and then I'm going to divide by 2y, so I'm actually going to get y prime is negative x over y. Okay, so this is our y prime. Okay, we might need that at some point. So now I'm going to do the second derivative. So here I have an equation that's solved for y prime. Okay, so now I do d by dx, okay, of y prime is equal to d by dx of negative x over y. Okay, so the derivative of y prime is just y double prime. Okay, so notice for the second derivative, I actually don't have to really solve for the second derivative, but I do need to simplify. Okay, so now I'm going to do the derivative of I'm going to have to use the quotient rule. So the derivative of the top is negative 1 times y minus the derivative of the bottom is y prime times the top, and then it's all over the bottom squared. Okay, now what I want to do is I don't want to have y prime in my answer. So what I'm going to do is replace it with what I know y prime equals. Okay, so then I'm going to have y double prime is equal to negative y minus negative x over y times negative x, okay, all over y squared. And if I simplify this, this is negative y minus, because there's 3 minuses, x squared over y, all over y squared. Now this looks ugly, so I'm going to multiply by y over y to make it look a bit nicer, and I'm going to factor out a negative. So I'm going to have negative y squared plus x squared over y cubed. Now here's another little nice trick that happens occasionally, not all the time, but I know that I can simplify x squared plus y squared, because from the equation, that's equal to 4. So in fact, my y double prime here is going to be negative 4 over y cubed. Okay, that doesn't always happen, but here it did, which is kind of, it makes it look a lot nicer if you recognize that you've seen that before. Okay, let's try another one. Here we need to be a bit careful about space. So we take the derivative, so we find the first derivative. I need to use the product rule for this term. Okay, so it's going to be 2x times y plus the derivative of y, which is y prime, times x squared, minus the derivative of 4x is just 4, and that's going to equal 0. So only one term has a y prime, so I'm going to move the other terms to the other side. So I have x squared y prime is equal to 4 minus 2xy. Okay, so then I get y prime is equal to 4 minus 2xy over x squared. Okay, so this is my y prime. Now, I want to take the second derivative. So I take the derivative of both sides. So I'm going to have y double prime on the left, and then I'm going to have to use the quotient rule here. Or I could actually simplify this and use the product rule. I wonder if that's nicer. Whatever, we'll use the quotient rule. So I'm going to take the derivative of the top, okay, times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Okay, so the derivative the derivative of this first part is actually quite complicated. So the 4 goes away, it's 0. But then I have to use the product rule. So the derivative of negative 2x is negative 2 times y plus the derivative of y is y prime times the negative 2x. Okay, so that's the derivative of the first part, and that's going to be times x squared. Minus the derivative of x squared is just 2x, so that's times 4 minus 2xy, and then it's all over x to the power 4. So I'm going to expand these things in so that I can simplify. So I'm going to have negative 2yx squared minus 2x cubed times y prime minus 8x plus 4x squared y. And all of that is over x to the 4. Okay, so I'm seeing some like terms. Okay, so I can put those together. But I also see this y prime. Okay, so I'm going to have to replace that with what y prime equals. Okay, so combining the like terms, the 4x squared y and the negative 2yx squared is going to become 2x squared y. And then I'm going to have minus 2x cubed times 4 minus 2xy over x squared minus 8x, and this is all over x to the 4. Okay, so I just put in, so this thing here is just, this is y equal to y prime. Okay, now when I simplify, this x squared actually cancels with 2 of these, so I just have 1 left. So I'm going to get 2x squared y minus 8x plus 4x squared y, and then I have the minus 8x all over x to the 4. And again, I have some like terms. So y double prime here is going to be 6x squared y minus 16x over x to the 4, which, so I could cancel out an x. So it's going to be 6xy minus 16 over x cubed is going to be my final answer for my y prime. Okay, so that's doing the second derivative implicitly. So we did both of them implicitly. So what you want to do is solve for y prime. That makes it a lot easier because then you don't have to solve for y double prime. But then you're going to have to input, so you end up with a y prime, at least one, in your y double prime, and you want to insert what that equals. Okay, so you want your answer in terms of only x and y at the end. Okay, so you don't want to have a y prime in your answer. And if you're lucky enough that you can use the original equation, you can do that as well. I don't think we were here. No. But if you are, you can also use that.